Okay, we're going to do another example problem here. This is number 2 on the same sheet as before. On this percent yield calculation, you're being asked to find not the percent yield, but you're actually being asked to find the observed yield. In other words, predict how much you should make in the lab if your reaction in this example is 89.15% efficient, or yields 89.15%. Now, the first thing to do, as with all stoichiometry problems, is to balance the equation first. So we're going to balance this equation, and again, we won't take a lot of time talking through this because I think by now you guys are pretty good at balancing equations. This is 4, 5, 6, 4 in our balanced equation here. So this question is suggesting that you're given 107.2 liters of ammonia, and you're trying to find out how much nitrogen monoxide you should be able to make, how much NO we should be able to make from that. And then at the end, we'll go on and adjust it for the fact that our reaction is only 89.15% efficient. Now, you can probably tell this will be a stoichiometry problem, and you know that compared to the previous problem, there's only one amount or one number here that we could start a stoichiometry problem with. We don't really have a way of starting a stoichiometry problem by using a percentage. So the only amount that's really useful for us to start the problem is 107.2 liters. So 107.2 liters of ammonia. That'll be our starting quantity. And what are we trying to solve for? Well, we're starting with ammonia, and the only other substance in the question is nitrogen monoxide. So here's what we're trying to get to in the end. How much NO should we be able to make? So at the end of our stoichiometry problem, we want to end up on nitrogen monoxide. First step in stoichiometry, we've got our balanced equation. So next is to convert this to moles. 1 mole of ammonia, as with any gas, if this is liters in the given amount, then you need to use liters in your conversion. And any gas is 22.4 liters per mole. Those units of liters cancel out. And now our next step is the mole-mole ratio, that critical step in stoichiometry that links two substances to each other. Well, we know that in this example, 4 moles of ammonia will give me 4 moles of NO. So this is a 4-to-4 ratio. We're trying to get to NO, so that one's going to be on the top. But the other way, and probably the more consistent way to think about what goes where, is to remember that those units that you have should come down so that they go away, that they cancel out on the next step. So we can say that 4 moles of NH3, according to my balanced equation, I use this 4, will produce 4 moles of nitrogen monoxide, like so. And again, those mole units cancel out, and we've switched over to nitrogen monoxide just like that. And the last step is to get it into units that we can measure in that lab again. We can measure liters, we can measure grams. We can't measure moles very well directly, and so most problems won't ask us to stop there. We're going to switch this one over to grams. So the very last step is to say that for 1 mole of any substance, we can find out how many grams are in it by going to the periodic table and adding it up. Remember, that's that molar or formula mass that we talk about in class. Well, if you go to the periodic table, excuse me, if you go to the periodic table and add up NO, you'll come out around 30. So 30.01 grams of NO. And that'll cancel out our moles and give us an answer in grams of nitrogen monoxide. Now you can go to your calculator and punch this all in, and I'm confident you'll get the right answer as well. This comes out around 144 grams of nitrogen monoxide. Now, that quantity, again, is our expected or theoretical yield. If everything goes perfectly, we should be able to make 144 grams. But this question is telling us this reaction, like all reactions, tends to be imperfect. And this one only yields 89.15% on a regular basis. So, to figure out how much we actually are going to make, which is what the question is asking, how many grams would be produced, not should be, not could be, but actually would be produced, we're going to take that expected yield, 144 grams of NO, again, our expected yield, and we're going to take that times our percent yield, but we're going to write it as a decimal. Because you know that 50% is the same as 0.5, and 75% is the same as 0.75. So we're going to take that percent yield and write it as a decimal. Essentially, we're getting rid of that times 100 part in our percent yield calculation. And so 89.15% written as a decimal will go in here as 0.8915. Right. And that'll give us our observed, or our sort of in the lab, observed or experimental yield. If everything goes according to that reaction, and at about 89.15%, we should be able to produce this quantity. And if you go into your calculator and do the math, this comes out around 128 grams. This is how much we should actually make. You potentially could have made 144 grams. Your reaction is only 89.15% efficient, and so you'll actually only be able to make 128 grams of nitrogen monoxide. So the word observed here is a little bit misleading in some ways, because observed feels like it's something that you actually went in the lab and did measure, and you've seen it already. It seems past tense. Here the word observed yield means that you're able to say in advance, this reaction is 89.15% yield, and so I'll only observe in the lab a mass of 128 grams. It's almost like you're predicting the future. And when we know a reaction's efficiency or its percent yield, we can very accurately predict in the future how much we'll be able to make. And this is an important thing in chemical industry or in manufacturing or anything. When you know you're going to waste some of your product along the way, and that you're only going to get 89% of it, then you can kind of adjust and be able to make the amount that you still need later on. So more on those applications as we go, but that's another example of percent yield. And with those two examples in hand, there are 4 other problems on your sheet. Hopefully you'll be able to work your way through those and get to answers that are quite similar to this in terms of a setup and in terms of your answers at the end. Work your way through those best you can, and check with your teachers for answers and help as you need it. Talk to you then.